Assalamualaikum and hello. Let's continue in this video about classification of carbon atoms and hydrocarbons. If you still remember about carbon atoms, it can form covalent bonds with atoms of another carbon or other elements. For example, we write the electronic configuration for carbon. We have carbon, C is the symbol for the carbon, and we got 6 electrons. As you see here, for the proton number for the carbon is 6, and of course we have 6 electrons in one carbon atom. Then the electronic configuration is 1s2, 2s2, 2p2. And if you take a look here, this is n equals to 1, the first shell, and this is n equals to 2, the second shell, and this is your valence shell. As you see from here, you got 2 electrons in 2s orbital, and you got another 2 electrons in 2p orbitals. So the total electrons is 4. So that's why carbon has 4 valence electrons, so it can achieve octet configuration by forming 4 covalent bonds. And carbon atoms also can form single, double, or triple covalent bonds with another carbon atoms or another elements. As you see here, I got a few examples for the structure of carbon with 4 single bonds. And I also got here the structure for a compound with carbon attached to oxygen. In the middle of them is the double bond. And the last one, I also got the structure for HCN. And you can see from here, there is a triple bond between carbon atom and nitrogen. For the next part, we are going to focus about hydrocarbon compound. So what is hydrocarbon compound? It is an organic compound consisting entirely of hydrogen and carbon atoms only, and it's divided into 2 parts: saturated hydrocarbons and unsaturated hydrocarbons. The first example for saturated is just only for alkane, where in alkane, the structure for alkane only consists of carbon-carbon single bond. For example, I got ethane with 2 carbons and 6 hydrogens. Next one, I got unsaturated hydrocarbons. There are 3 examples for unsaturated hydrocarbons. The first one is alkenes with 1 or more carbon-carbon double bond. The example is ethene with 2 carbon atoms and 4 hydrogen atoms. The chemical formula is C2H2. The next one, we have alkyne, where it is a compound with 1 or more carbon-carbon triple bond. For example, I got acetylene with 2 carbon attached between each other with triple bond and 2 hydrogen in its compound. The next one, I got arenes with 1 or more benzene like ring. As you see from here, I got the simplest example for arenes, which is benzene itself with 6 carbon atoms attached to each other with alternating of double bond and single bond, and each of carbon atoms is positioned in a ring with 1 hydrogen attached to them. Once you've known about hydrocarbon compounds, now you can classify the carbon atoms in hydrocarbon compounds. To classify carbon atoms in organic molecules, you need to know that there are 4 types of carbon atom. The first one is primary, and it means that 1 carbon atom bonded to 1 carbon. Next one, we got secondary carbon atom with 2 carbon atoms bonded to 1 carbon. And the next one, we have tertiary carbon atoms with 3 carbons bonded to it. And the last one, we have quaternary carbon atom with 4 carbon atoms bonded to the center of carbon. And if you take a look at this picture, you can see that we focus the red carbon as it. And with one carbon next to it on the left, it means that this is going to be primary carbon for the red one. The next example, I got the red one with another 2 carbons attached to it. So this is going to be secondary carbon. And the next one, we got tertiary carbon with 3 carbon atoms attached to the red one. So this is going to be the tertiary. If you want to label, you can label it like this. An arrow show to the carbon that you want to label with this symbol. So now we are talking about tertiary carbon, or you can label it like what I write here. When you want to do the classification of carbon atoms, you have to make sure the carbon that you want to classify only has 4 covalent bonds. So it means that 4 single bonds attached to them. If you take a look here, there is no double bond in the examples that I show here. So that's why this rule is very important for you to classify that carbon atoms. For the next one, we are going to classify hydrogen atoms in organic molecules. The most important thing, you have to know that there are 3 types of hydrogen atom, quite different from the carbon atom. We got only 3 here: primary hydrogen atom, secondary hydrogen atom, and tertiary hydrogen atom. So primary hydrogen atom means that hydrogen atom that you want to classify is bonded to primary carbon. Secondary hydrogen atom means that hydrogen atoms that you want to classify is bonded to secondary carbon, and same for tertiary. So it means that you have to understand the class of carbon atom. If you know how to classify the carbon atom, automatically the class of hydrogen atom attached to that carbon will be the same class with it. Now, let's try example with me. I want you to classify certain atoms in this molecule. Specifically, I want you to classify HX, CX, CY, CZ, HZ, and CV. So, in order for you to start, please remember you have to start classifying the class of carbon atoms first. And then after that, continue with the class of hydrogen atoms. So let's go to CX first. As you see from here, the first rule, take a look around the carbon atom whether all bonds are single bond. So you see from here, we got 4 single bonds. It means that yes, you can classify CX. And take a look at CX. You have CY attached to it. So 1 carbon atom attached to CX. This means that CX is primary carbon. That's how you write your answer. Next one, when you want to classify the hydrogen atom, which is in this case HX, automatically HX will has the same class as CX because HX is attached to CX. So you will write it with an arrow pointed to HX with primary hydrogen. Next one, let's go to CY. So take a look around CY. We got all 4 single bonds. Yes, it means we can classify CY. And the next one, take a look how many carbon atoms attached to CY. We got 1 here, 2, 3, and 4. So 4 carbon atoms attached to CY. So the class of CY is quaternary carbon atoms. Next one, we got CZ. So CZ also got 4 single bonds attached to it. So then we can classify this one as well. And we got 2 carbon attached to CZ on each side. So how you want to classify CZ? You will label as secondary carbon. The next one, when you want to classify the hydrogen attached to the same CZ carbon, so HZ will has the same class as CZ. So HZ is secondary hydrogen. And last one, you take a look at CV. So now we got single bond on the left, single bond on the right, and double bond O at the top. So can you classify CV? In this case, no, because when you want to classify the carbon atoms, you have to make sure that carbon atom will has 4 single covalent bonds. So in this case, I will not label anything because CV cannot be classified. So I hope from this example 3, you can strengthen your understanding how to classify the carbon atoms and also hydrogen atoms. And please make sure you know how to differentiate between different saturated hydrocarbons and unsaturated hydrocarbons based on this video. You can try to attempt exercise 4 for more better understanding. So that's all for this video from me. I'll stop here and I'll see you in the next one. Bye!